In the last video, I introduced the SI unit system, and at the end also tied it into the standard American equivalents that are used in the United States. So here, I thought it'd be useful to work through a few examples of how to convert, and also spend some time on the metric prefix system. So let's do a quick review of metric prefixes. If you see some distance, like say 17 kilometers, the way this works is this bit right here is known as the symbol, and this bit here is known as the prefix. Now the way I learned this, and it doesn't seem to have been super common, but I figure I'll pass it along in case you find it helpful, is I learned this as the instruction multiply by 1,000. So when I see 17 kilometers, this K here, because it's a prefix, I can replace that with the instruction times 1,000. I still have to leave my meters, but now I know that I have to multiply 17 by 1,000 to be left with 17,000 meters. And so that's how I would know how many meters are in a kilometer. By the same token, if say I had, 42 centimeters, when I see that centa prefix, I view that as the instruction divide, by 100. So I would look at that and say, all right, 42 centimeters. That C in the prefix means divide by 100, so I can take 42, I replace the C by divide by 100 meters. So I have 42 divide by 100, still left with meters. If I take 42 and divide by 100, I get 0.42 meters. Some of the prefixes that you're likely to be running across in this course, you might run across mega, which is capital M. So that it should just be viewed as the instruction. Whenever you see it, you can replace that mega with times 1,000,000. You'll definitely run into the kilo prefix. Whenever you see that, you can replace that with its instruction, times 1,000. When we get to dealing with pressures, very briefly, we might go deal with the hecto prefix. When you see that, you can replace that with the instruction times 100. Other prefixes that were likely to be seen in this course will be centa. When you see that, you're going to replace that with divide by 100. And milli, not to be confused with meter, so the position matters. Replace this with divide by 1,000. Okay. So for things that are more than just popping the decimal point back and forth, or get more complicated, I become a fan of what I like to call the Fencepost method. I think some people call it that. I don't know if everybody does. But let's just take, for example, let's say you had the traditional unit, 14 furlongs per fortnight. And you wanted to figure out how many meters per second, that is. A way you can do this is the strategy is you just keep multiplying by the number 1, but doing it in clever ways. So we can start by writing our fraction out, 14 furlongs per fortnight. So I've got two things I have to do here. So this is, we need to develop a strategy. And my strategy is I need to get my furlongs to meters somehow. And I need to get my fortnight to seconds somehow. Let's do the fortnight to seconds. Hopefully that will go at least a little bit better. So I know that one fortnight is 14 days. So that isn't seconds, but that gets me closer to seconds, right? You know, that's more like seconds than a fortnight is. And notice here what I've done is I've multiplied by the number 1, but I wrote it as a fraction. 1 fortnight over 14 days. These are both the same thing. So this is just the number 1, because I got the same thing, the numerator and the denominator, just expressed in different ways. And the reason fortnight is in the numerator is because I need to cancel this fortnight in the denominator. Now, days aren't seconds yet, but I could turn them into hours. And again, same kind of deal here. I got days in the denominator, and I need to cancel them. So I'm going to have days up in the numerator. And then I can put 24 hours in the denominator. And again, same deal here. Cancel, cancel. All right, we can keep this game up here. I can do an hour in the numerator and put 60 minutes in the denominator. And then I can go and put a minute in the numerator, put 60 seconds in the denominator. Yay, I've hit my target unit here. And while we're going along, we should probably make sure that our units are continuing to cancel. And they are. So now what I've got is in the numerator I have 14. In the denominator I have 14 times 24 times 60 times 60. At the end I'll be multiplying the numerators and the denominators together, doing one division. At the moment I have furlongs per second. Now this particular example is kind of ridiculous. So we're going to have to continue it out onto the next line here. So furlongs. Okay, I need a furlong in the denominator. And here, the thing that I know is more useful to me is I know that 1 mile is 8 furlongs. Now that seems to be heading away from where we want to go. But when I say heading toward, sorry about that, when I say heading toward or away from where you want to go, I mean as in being able to look things up. So there's 8 furlongs in a mile. Okay, good. So the furlongs cancel. The reason I went with the mile is because I know how many feet there are in a mile. So I need mile in the denominator. And then we can put 5,280 feet in the numerator. Now, I happen to remember from the previous video how to get from feet to meters. So that's why I went this way. So I can put 1 foot in the denominator. So again, the feet cancel. As long as I put what a foot is in the numerator. And in the numerator, that will be 0.30448 meters. Because since we're doing standard American equivalents here, by definition, that is exactly a foot. Okay, so at the end of this, all of our units are canceled except for a meter sitting here in the numerator and a second sitting there in the denominator. So the answer we get is going to be in meters per second. All right, so what have we got? Well, multiply all the numerators together. So it's 14 times 1 times 1 times 1 times 1 times 1 times 5,280 times 0.3048. Now what do we got here? 14 times 24 times 60 times 60 again times 8 in the denominator, and make sure to carry your units. And this works out to be 0.0023 meters per second. So this is pretty literally a snail's pace. We're talking about moving at 2.3 millimeters a second. But there you go. Now, most unit conversions you do will not be this involved, but I wanted to just thread this together to show that if you do get something horrendous, just keep working in the direction of towards something you understand better that's closer conceptually to the thing you need. Okay. But when we do this method, we do have to be a little careful, especially when you're doing areas or volumes. But let's do an area as an example. So let's just convert 1 acre to some number of square meters. Okay, so we can start with just writing 1 acre. And we don't have to put it over anything. And we can remember that there are 43,560 square feet per acre. All right, that's good. But now here we've got to be a little bit careful. Because you're tempted to just say, oh, hey, I know how to convert feet to meters, right? 1 foot is 0.3048 meters. But look out here. You have 2 powers of feet here, only 1 power of feet there. So you can go ahead and cancel this out. That's cool. But this is still going to leave you with feet times meters. So we only canceled out 1 power of feet. So you'll have to do it again. So you'll need another 0.3048 meters, another 1 foot. And now those cancel nicely there. And now you're left with meters times meters is square meters. So following our recipe, we're going to be taking 43,560 times 0.3048 squared, because we've got 2 of those powers, and don't forget your units. We've got meters times meters here, so that's going to be meters squared. So this works out to be 4,046.86 square meters. And probably you shouldn't go as ridiculous as I did with the significant figures, but hey. Alrighty, so with that, I will catch you all in the next one.